Hello everyone, welcome to this part 3 of the OpenCV tutorial series. Here we are going to try and attempt to do a project. And this is about tracking a ball. You can see this video in front of you. The ball is moving around and the idea is to track the movement of the ball at any point. So from a human perspective, we know where the ball is moving. It's moving right, left, right in random fashion. But how would you do that from a computer vision perspective? How would you make a computer understand where the ball is moving? So let's get into that. So the first thing we want to do is, of course, import OpenCV. Let me make this a little bit big, maximize this everything so it's very easy for you to read. Okay, we have import CV2, import numpy as np, and from Google Colab patches, import CV2 underscore INSHOW. Before we do all this, let's go ahead and clone the repository. And if you go into the table of contents and OpenCV page 6, the first step just above the part 1 is where the GitHub repository is, and we do want to clone this repository. This will allow us to access some of the project files that we are going to be using in this particular project. So you have the OpenCV tutorial folder, and inside this, you'll see this videos folder. And in this videos folder, there's a video file called video.mp4. And this is what the file or the ball tracking file is that we'll be using. Okay, let's come back to the table of contents. Let's go into a project, which is the tracking a ball. Let's continue our coding. So right now we have just imported the libraries that we need. The next thing is, let's open the video file that we just saw. So we can call, OpenCV has this function called video capture, which is basically able to read a video file for us. So we'll create a capture variable called cap equal to CV2 video capture. And this video capture is able to read a video file or even a webcam for that matter. If you wanted to read a webcam, of course, you can't do this on a Colab. You can do this on your own desktop computer. And if you just put down 0, it will start reading the default webcam that's connected to your computer. But instead of that, let's read a video file that we have here in this Colab. So we have it under the folder called videos / video.mp4. So coming back again, just to make sure, we are under the OpenCV tutorial folder, and inside that there is this videos folder / video.mp4. That's the file that we are going to read through our capture variable. And this capture variable is capable of reading through every frame of the video file for us. And the way we do that is by reading, hey, capture, give me a frame from your video file. And cap has this function called read. This read function is able to read through the video files and then give out the frame that we want. But now a video file consists of multiple frames. It has millions of frames, hundreds, thousands, many frames that are stacked on top of each other. Then when they play in a sequential format, it looks like a video. So if we just read it once, it'll just give you the first frame. If you read again, frame equal to cap.read, it will read the second frame. Similarly, if you read it again, it'll read the third frame. So you have to keep going and throwing and reading through all the video frames. That's a very cumbersome format, and you really don't know how many frames there are. So instead of reading them individually, we will read them through a while loop. And we will open up a while loop. We'll say, hey, while loop, please start reading the video file for us. But you want to read the video files only and until the videos start or spitting the frame files. So it should read only until the videos have enough frames to read. And once the video comes to the end of its file, you should stop reading. Otherwise, you'll be running in an infinite loop. So we'll say while cap is open. And this flag is capable of reading whether or not there is something reading through the video file or not. And then now we will read the frame. We'll say frame equal to cap.read. So it will read through all the frames of this particular read function. It will go through all the frames that are available in the video file and then give it in our frame folder. Now, OpenCV also allows us to do some debugging. It allows us to make sure what we read is good or not. So it has a flag, and we'll call this the red flag. And this flag is capable of letting us know whether or not there was a frame read or not. So if there was a good frame and if a real frame came out of this video file, then this red will be equal to true. Otherwise, it will be false, stating that no, there was no frame read. So you don't need to take care of anything. The frame is nothing. So this red flag helps us also keep a checkpoint stating that, hey, is there a frame or not? And if there is a frame, continue with the next process of the project. But if there is no frame, then don't bother. So we'll keep a if statement. We'll say if red is false, don't bother. Don't bother the while loop. Don't bother continuing with the project. Just break out of it. And this is a condition that we will create just reading the red flag. This flag is able to, it's whether or not there was a success or not, whether a frame is read or not. That's all we're doing here. And this frame is now going to be read through all the frames of the video file, and subsequently, sequentially, it will have all the frames one by one. Now let's see what we should be doing with this frame file. This frame file, we are interested in identifying the color of the object, and we are also interested in identifying where the object is in the video. So we did in the previous projects, in the previous lessons, we looked into color detection. In this color detection, we saw how we could detect particular colors. Like you had the yellow color, the green color, the red color. Now we know our ball in this particular video is of yellow color. So we can maybe use this particular code. We can create a mask. We can do some bitwise and find the position or where the yellow color is located. That's a cool thing to look into. Now, coming back, we'll use that same system for our current project, and we will do some yellow color detection. And for that purpose, what do we need to do? First thing we have to do is convert the color into a HSV image. Again, the reason I'm going through this is because we have already covered this in the previous lessons. And if you need, you can always go back to the color detection, color changing profiles, and you will understand what we are doing here. So we are now converting it into a HSV image, and we use CV2 color BGR to HSV. We bring it here. So you can see that it's now converted into a HSV image from a RGB or a BGR image in OpenCV format to HSV image. This HSV is now able to help us detect the yellow color specifically. And we saw there was a lower bound and upper bound of hue, and we will use that here. So let's go back to this code, and you have the color detection. And it's easy to copy and paste the colors that we saw here. We have the lower hue and the upper hue, and we'll copy this. I'll press the Control-C button, and coming back to where we were, the table of contents, we want to go into the project folder, and here we will paste what we need here. This needs to be a little bit indented. So here lower hue is representing the lower bound of the yellow color, and the upper hue is representing the upper bound of the yellow color. The next step we want to do is create the mask, and the mask would be given by using the CV2 in range function. So in range is going to look into the image, and wherever the hue value lies between these two ranges and the hue, saturation, and variance values lies between this range, it will give out all those pixels in a different color. So it will highlight those pixels for us particularly. So we'll say, okay, CV2 in range function, do your in range magic on my HSV image using the lower hue and the upper hue range that I have created for you. So good job. You have created the mask. You have now identified the yellow color specifically in the video. Good. Now, what is the next step? The next step is to identify where this yellow color is residing. And for that purpose, we used a function called find contours. And we did find contours just in the previous function. If we go right here, in the previous function where we did draw contours, find contours. So this is the previous lesson that we covered where we were doing shape detection when we were using find contours to identify the different shapes that are available, different colors, and then also draw those contours. And we will use some of these functions in our project as well. So coming back to the table of contents, project, coming back to this place. So we have the mask, and we have now going to create all our contours. So the contours function, we will create, okay, contours, and all, whatever x the contours function is able to give us, we are not interested. We are only interested in the contours that the find contours function is going to help us find. So there is a function called CV2 find contours. This contours function is now going to help us in identifying the different contours that are available in the image. And this function needs the mask that we just created. It also needs some sort of functions that are going to specify what kind of a contour detection it's going to do. So in this case, we are going to be using the pre function, and we call it as the CVT RETR tree. This is just understanding these are different types of contour detections, and we are just using a specific type for our project. It doesn't matter. It's a simple contour detection that we're doing here, and it's not going to affect what type of contour detection you use. And this the approximate approx simple. So these are different types of filters that are used, a different algorithm altogether, and we will be just using that to detect our contours. Once we have the contours detected, well, good. The next thing we want to do is then try to identify where these contours are. So we'll say, okay, for now, I don't know where the contour is. So I'll say that contour has a center point, which I don't know. And for now, I'll put it as just none. Now, if my frame has contours, so if my length of contours is greater than 0, which means that I have contours in this, otherwise it'll be 0. So if my contours is greater than 0, yes, let's go about and identify where my contours are located. And for that purpose, we will first identify which is the maximum, the biggest contour in my image. And for that purpose, we'll say, hey, C, which is the maximum contour, use the max function of Python to detect which is the biggest contour of all the contours. And you can use the key function. And for how do you identify which contour is the biggest? You are going to use the CV contour area function. The CV2 contour area is able to give you out the different types of contours and their areas, and it will give out the maximum size of the contour. And you can store that under this variable called C. Once you know which is the biggest contour, good. Now let's find out where this contour is located. So initially we detected that it's a center of none, but now let's try to identify where exactly, what is the coordinate. So now we can use a tuple called x comma y, which is going to be the center coordinate and the radius. And OpenCV has this function called minimum enclosing circle. And this minimum enclosing circle can take a contour, whatever contour you give. And in our case, we're going to give this contour called C. And it's going to take that contour and identify what would be that circle, what would be that minimum circle that can enclose the whole contour. And what the circle is defined by the center point and the radius. That is the circle which will be enclosing this contour that we have here. So now you know where the center is, you know where the radius is. So very good. Now we also want to identify where exactly the moment file is. So we have the moments which can be given as m equal to cv2 moments. So this is another way where you can identify the center of the contour by using moments. Moments is nothing but specifying where the center of the mass is, where the centroid or where the main center of the contour is located. And for that purpose, we'll use a try function because it's prone to errors. And we will say, hey, try to find the center. And I'll say center is equal to, there is this formula. And it's going to sound a little bit confusing here, but stick with me. What you're just basically identifying is the moments of different types of contours, of different location of the different coordinates of the contour. And based on that, it can identify where the center or where the centroid of that contour is located. And that formula is given by int moment. And this is an array, which is given by 1, 0, which is nothing but the corner, one corner. And then you are also dividing this by another moment, which is given by m00. So these are two moments which we are just defining, and that's the x coordinate. Similarly, the y coordinate is given by int moment and specifying which moment is this, the next coordinate. And then you're also dividing this by the base, which is given by m, and you have m00. You're just defining where the center of the coordinate is. So once you have the center, now you can also identify where to draw these centers. So we can draw the center, CV2 circle, good. And your frame, you're going to draw on the frame, the original frame that we had, and we're going to draw using the center of the image. Good. So we have the center, and we're going to say, okay, the radius of this circle is going to be, say, 10. And we are going to give a color of maybe blue color, 255, 0, 0. And we're going to fill this, or the thickness. Thickness is going to be -1, which is nothing but specifying that the whole circle should be filled with this color. Okay, good. So now we have drawn the circle. Now this circle, this center is specifying one location, one point of the ball. Now we are interested in identifying all the different types of contours that can be available. So you want to store the center of this ball at every instance. So for that purpose, let's define an array. An open array will say ball is equal to an open array. Right now, we don't know what this ball is going to have, but this ball is supposed to have all the coordinates of the center of the ball at any instant of the video. So this ball array is going to host or have the center coordinates of the ball wherever or whenever it is moving in the video. So we'll say ball dot append. Append is just adding to the array. Append the center, which is the coordinate of that ball. So you just right now storing the location of the center into the ball array. So good. And if there is an exception, go ahead and pass. We're not going to bother about it. Now we have the center of the coordinate. We drew the circle at that instance, and we are also appending the center, which is very good. Now let's use this ball array to draw the track or the movement of the ball. So for that purpose, we'll say if the length of ball is greater than 2, because the reason I'm saying greater than 2 is because you want to draw a track. A track is nothing but a line, and the line can be defined only by 2 points, a minimum of 2 points. So in order to draw a line, you need to have at least 2 points. And for that purpose, I'm asking, hey, ball, are you length of 2 or greater? If you're 2 or greater, let's go ahead and draw. So I'm just going to draw this now. For I in range of I in range 1 to length of ball. So I'm just going to loop through all the elements, all the center coordinates of the ball, right from 0 to the length of the ball. And we're going to say, oops, let me put the colon here, and we'll say draw the line or the track that I'm interested in on the frame using ball's initial coordinate, which is the -1, which will be the 0th or the index 0, and the next point, which is the ball I. So between these two coordinates, between these two center points, go ahead and draw the line that I need. And give me a color of red. We'll say 0, 0, 255, and a thickness of, say, 5. Okay, so now you're able to draw a line. Perfect. Now this is where we are able to show that, yes, our OpenCV project is able to draw, not just detect where the circle is, but at the same time also draw the line showing where the ball has moved. So very good. Now, how do we take this information? How do we show it to the end user that we were able to do this? Since it's a video file, if we start displaying it here on Colab, it'll be a big mess. Instead of that, not only we will read this video file, but we'll also save it as a video file. And OpenCV allows us to create videos. So using a video writer function. So we'll call a variable, like we call the variable capture to read videos. We'll call a variable called output or out, and we'll say OpenCV, use your video writer function to write a video file for me. And for that purpose, you're going to create an output AVI file. And this output AVI file is going to have the type of the video that we are interested in. You're going to store all the new frames that you just created into that. So we'll say, okay, very good. I'm going to create this output.avi file, but what kind of a video file do you need? There are different types of video files. There's different types of compression of video files, I should say. So there is the MJPG, which is nothing but moving JPEG, moving JPG images. So we'll use that, and there are different other types of compressions, and we will use MJPG, which is moving JPEG. We'll say CV2 video writer, and this 4cc. Oops, 4cc. And this 4cc is nothing but the video codec that we are interested in. And in our case, we'll say MJPG, oops, capital G. So we have MJPG, which is the type of video codec that we are interested in. We are also going to specify the number of frames per second. In our case, it will be 10. And we also need to specify the size of the video. And the original video that I had created, the video.mp4 that we used, That was at a resolution of 1920 by 1080. So we'll create the same video file, same size. You can use whatever size you want, but just so, because I'm doing a screen recording, if I do something lower, it might come out very bad on the screen. So I'm saving it as a 1920 by 1080. Now this output file, oops, keeps jumping out. Okay, so this output file is able to write whatever frame that you are interested in this output.avi folder or AVI file, video file. So we have this output function, like we use the capture function and we use capture.read to read through all the frames. Similarly, this output function is capable of writing the frames. So we can say out.write frame. And this out.write will just simply write the frame that we newly created here into the output.avi file. And it will loop through all the frames until this while loop is finished, until the red flag says no more frames available. You went through all the frames, so you're done. And until it does that, it will go through and write all the output frames for us. And once everything is done, it will go ahead and you can release the output file. I think this should be indented a little bit on the left side because we're doing it in the if length contour side. So we want to do this once it's out of the if statement. At the final end of the while loop, once you have done all the manipulations that you want to do on the frame, and then just simply write the file onto the output.avi. So good. Now let's go ahead and run this. Let's see if we come across any errors. And it's taking a few seconds. It's running through all the frames for us. Okay, so it seems to have run, and we can now open this file and we can see under the videos, not under the videos, under the output main OpenCV tutorial folder, you have the output.avi, and I can simply click here and press download, and it will give you this output for us.